In today's lesson, we shall go through differentiation. An introduction had been done in our previous lesson, whereby assuming we have a function, the function of x is equals to ax squared plus bx plus c, given that this is a quadratic function, and assuming that the value of a is greater than 0, then we know that the graph, the sketch of the graph will be looking as such. Now, if then you're being asked to find the gradient of a particular point on the curve, you would be required to draw a tangent, find the gradient of the tangent, which then gives you the gradient at that particular point. So what I've just mentioned is that when you draw a tangent, you find the gradient of the tangent, which gives you the gradient of the curve at that particular point. At that point. Now, remember, rather than go through all these steps whereby you have to draw a graph, draw a tangent, find the gradient of the tangent, and thereafter find the gradient of that curve at that particular point, it is then easier to use differentiation. Why? Under differentiation, if you have your function y equals to ax squared plus bx, your dy dx value will be 2ax plus b. And this here is your gradient function. And the reason why we refer to it as the gradient function, it is the function that helps you find the gradient of your original curve at any given point on the curve. So that's why we use differentiation to help us find the gradient rather than going through the steps of drawing a tangent, though we will still go through a question whereby we will be asked to find the equation of the tangent. Now let's look at an example. Question 14 on the screen. The equation of a curve y equals to a sixth 2x minus 3 into bracket cubed minus 4x. Find dy dx. So we are being asked to differentiate the equation of the curve. So we have the equation y equals to a sixth 2x minus 3 cubed minus 4x. So our dy dx, again remembering from a few lessons ago where we started learning differentiation, we shall have 3 over 6 times 2 into bracket 2x minus 3 using chain rule minus 4. And this is simplified as these will all cancel out, so we'll be left with 2x minus 3 squared minus 4. That's our value for dy dx. Now, after doing so, I would like to clear this with the exception of the dy dx and the original curve. The question asks, find the equation of the tangent to the curve at the point where the curve intersects the y-axis. So I would like to bring to your attention two things. First, we are being asked to find the equation of the curve, the equation of the tangent to the curve, And secondly, we are being asked at which particular point where the curve intersects the y-axis. So we are going to do the first part, whereby we are going to find the equation of the tangent. Now, to find the equation of the tangent is a straight line. So this is the equation of the tangent. The equation of the tangent, given that this is a straight line, we know that the format of a straight line equation is y equals to mx plus c. Now, we need to know the point whereby the tangent meets the curve. And we are told from the question that at the point where the curve intersects the y-axis. So the original curve, this curve, at what point does it meet the y-axis? So at the y-axis, or at the y-intercept, or if we are trying to find the y-intercept is a point where the curve meets the y-axis. We do know that the value of x is 0. So we are trying to now find what is the y value. So we shall take our original curve, this, and substitute x with 0. So we shall have y equals to a sec into bracket 2 into 0 minus 3 cubed minus 4 into 0, which becomes a sec to bracket 0 minus 3 to bracket cubed minus 0, which will be a sec into bracket negative 3 cubed, which is a sec into bracket 27. So we do know that the y value is 27 over 6, negative 27, excuse me, because this will be negative. So the y value, or the y-intercept, is going to be negative 27 over 6. I will go ahead and clear this part. Now we do have the point whereby the tangent meets the curve, and that point is 0, negative 27, 6. Taking you back, remember we had found the gradient function. And as we said, the gradient function is the function that helps us to find the gradient at any given point on the curve. Now, since now we are looking for the gradient of the tangent or of the curve at the point where x equals to 0, I will substitute x for 0 in the gradient function. And I will do it below here in green. So this is the gradient of the tangent or the curve at that particular point at 0, negative 27, 6. This will be 2 into bracket 0 minus 3 squared minus 4 equals to 0 minus 3 squared minus 4 equals to 9 minus 4, which is 5. So, and there we go. We have the gradient of the curve to be 5. So this is equals to be 5. The gradient of the tangent or the curve at that particular point where x equals to 0 is 5. So I can now delete our dy dx so that I can now go ahead and find the equation of the tangent. Remember, the tangent is a straight line, so it takes the form y equals to mx plus c. We have the value of y there, the value of x there, and our gradient there, negative 5. So I will go ahead and substitute to find the value of c. this will be negative 27 over 6 equals to 5 into bracket 0 plus 6. So negative 27 over 6 equals to 0 plus c, meaning that c is equals to negative 27 over c. I can therefore go ahead and find the equation of the tangent. Now that it should be in the format y equals to mx plus c, I can write the equation of the tangent to be y equals to 5x minus 27 over 6. And that's our answer. That there is the answer to the question, to find the equation of the tangent at the point 0, negative 27, 6. Now, the last part of the question, find the set of values of x for which 1 over 6, 2x minus 3 into bracket cubed minus 4x, which is the equation of the curve, is an increasing function of x. Now, I will do a reminder. An increasing function, in this case, I'm going to use a quadratic function. So imagine we have y equals to ax squared plus bx plus c, and a is greater than 0. It will look like that. Now, we have the turning point at that point, and similarly to a straight line whereby the line would be sloping down this way, the gradient of the curve from this point, all these will be negative. And similarly to a line that would be sloping up, the gradient of the curve from the turning point to the right will be positive. So what are we exactly saying? That for this particular curve, the gradient, I will delete the lines to help us see clearly, that the gradient at this point is negative. At the turning point, the gradient is 0, and to the right of the turning point, the gradient is positive. In the event we have a curve where we have y, same a curve, y equals to ax squared plus bx plus c, and a is less than 0, the curve will appear this way. And we can go ahead and indicate that the gradient, if the turning point is here, this gradient will be positive and this gradient will be negative. So, to conclude this brief summary, this is referred to as a decreasing function. The range of values at which it is a decreasing function. And this part are the range of values where it is an increasing function. So this part here will indicate the range of values of x for which it is an increasing function, and this part will be a decreasing function. So let's go back to our question. So we want to find the set of values of x for which the curve is an increasing function. So it's not all values. As you can see, it's a polynomial given that it's raised to 3. And we need to go back to our dy dx. Remember, we had found our dy dx to be 2x minus 3 into bracket squared minus 4. Why do we need our dy dx? Because we need to find the value of x at the turning point. And remember, at the turning point, the gradient at the turning point the gradient is 0. So I will equate our gradient function to x minus 3 squared minus 4 to 0, attempting to find the gradient of the value of x at the turning point. So this becomes 2x minus 3 expansion goes to 0, which finally becomes 4x squared minus 12x plus 5. Excuse me, it's 0, equals to 0. So we solve this function quadratically. I will do that very quickly. So depending on whichever method you will use, you will find that the first value of x is going to be 5 over 2, or 2.4, 2.5, that's correct, or x equals to a half. What does this mean? This means that we have two turning points. The first turning point is where x equals to 2.5, and the second one is where x equals to a half. Now, at both points, we are expected to now find out which of the two is do we have increasing function. I will clear this so that then now we will begin with when x is at the turning point where x equals to 2.5. I'll draw a small table here. At 2.5, which is the turning point, the gradient is 0. And I'll pick any point to the left of 2.5, and I will go for 1. And I will substitute 1 into the gradient function to find out if the value will be positive or negative. Why are we substituting 1 into the gradient function? Because we want to know what the gradient will be at that particular point. And if we substitute, we'll find 2 minus 3 squared minus 4, which will give us negative 3. And if we do the same thing, but at this point we are going to select a value which is to the right of 2.5, and we could go for 3. This will be 2 into bracket 3 minus 3 squared minus 4. And that will be 6 minus 3, so 9 minus 4, which is 5. So what do we see from this? That to the left of 2.5, the gradient is negative. So that means it is sort of sloping downwards. At the turning point, it's 0. And to the right of 2.5, the gradient is positive. So our first point to answer the question, the range of values for which we have an increasing function, is where x is greater than 2.5. Because we can tell from this that when x is greater than 2.5, the gradient is positive. Then we will attempt to do the same at the point where the gradient is a half. We draw the table and we have 0.5. At the turning point, the gradient is 0. To the left of 0.5, I will choose to use 0 and substitute it in the gradient function once again. So, and we shall have 2 into 0 minus 3 squared minus 4. We calculate that, we get the answer to be 5. And to the right of 0.5, I will use 1. And I will go ahead and substitute 2 to 1 minus 3 squared minus 4, which gives us negative 3. Now, what does this tell us? Once again, we can tell that to the left of 0.5, the gradient is 5, which is positive, which tells us that the gradient is sloping up, or the curve is sloping up. The turning point is 0, and at 1, it's sloping downwards. So, our second point, or the second set of values, is to indicate that the function is an increasing function where x is less than 0.5, because we can see at the point 5 the gradient is positive. So we shall go ahead and combine the two and indicate that it is an increasing function. The increasing function is at the point where x, at the range of values where x is greater than 2.5 but less than 0.5. And that there is our answer to that question. That the range of values for where we have an increasing function are values between where x is less than 2.5 and where the x values are greater than 2.5. I know I have covered quite a bit in that lesson, and we have brought in all the ideas we have from differentiating to understanding what is the gradient function, to finding the equation of the tangent and the gradient of the tangent, and finally knowing what is an increasing function and how to go about it. I hope you have enjoyed. Do contact us in case you have any question, and I look forward to seeing you in our next lesson. Thank you.